For over the last 50 years, Alco-based diesel locomotives have been the workhorses of Indian Railways. These locomotives replaced the highly maintenance-intensive steam locomotives and hauled Indian Railways into the modern days of heavy and fast trains, coupled with high asset reliability, cheap operations and low maintenance requirements. The prime movers on these diesel locomotives are 4-stroke Alco engines. This is an Alco power pack. Since most of the components in this engine are otherwise hidden within the engine block, we decided to cut open the engine block for you. So we asked someone to saw through the engine block like this. This is the front view of the cut section of the engine. The engine block with all its intricacies is visible here. The engine block is a welded structure formed of plates and channels. It is the main structural component in the engine, and all parts of the engine are supported on the engine block or built around it. This portion is the engine block. Below the engine block, bolted to the block, is the sump. Sump contains the engine oil. Engine oil, after circulating throughout the engine, falls back into the sump. The sump has a number of baffles to prevent sloshing around of the engine oil when the locomotive is on run. In this view, you see one large circle. This is the crankshaft of the engine. The usable power produced by the engine is available at the crankshaft in rotational form. Above the crankshaft, you see two small black circles. These are the two camshafts. Camshafts operate the inlet and exhaust valves and the fuel injection pump. This is a 45-degree narrow V engine. To the left of the screen is the right bank. To the right is the left bank of the engine. If we draw a straight line through the two banks to intersect at the center of the crankshaft circle, the included angle is 45 degrees. This narrow angle allows two cylinders to be fitted in a relatively narrow space, making for a smaller sized engine. The central triangular portion, painted yellow in color, is the V chamber. Air from the turbocharger is fed into the V chamber, which acts as the air intake manifold. This is conveyed to the engine cylinder through intake valves. The yellow passages show the path of intake or charge air. After combustion, this air turns into hot exhaust gases. The path taken by exhaust gases is shown in red color. Hot exhaust gases are allowed to escape by opening the exhaust valves. These gases go into the exhaust manifold at the top of the engine, from where they are routed to drive the turbine of the turbo supercharger. Fuel is injected into the engine in finely divided spray through a nozzle. The injection pressure is about 4000 psi. Such a high pressure is required in order to allow the fuel into the combustion chamber that already contains charge air at high pressure. Fuel is pressurized by a fuel injection pump mounted on the side of the engine. There is one fuel injection pump for each cylinder. The fuel injection pump decides the quantity of the fuel to be injected, pressurizes it, and sends it to the injection nozzle through a high pressure pipe. The energy for running the fuel injection pump, which is a reciprocating pump, comes from the camshaft. The process of combustion creates a lot of heat that needs to be removed from the engine. This is done by circulating coolant water through the engine block. The passages for coolant are shown in green color. You can see that each cylinder liner is jacketed by coolant that prevents temperatures from rising too high. This coolant is circulated through two large radiator cores with induced air draft to prevent it from getting too hot. The usual temperatures of the coolant in normal working conditions is between 80 and 85 degrees Celsius. We have connected the moving parts of the engine to an electric motor. The moving parts of the engine can be seen once we switch on the motor. One important thing to observe here is that the camshafts move at half the speed of the crankshaft. This is because this is a 4-stroke engine. You can also see that the two pistons are moving out of phase. This becomes necessary to balance the engine and prevent unduly high stresses from damaging the engine. The valves are operated by camshafts through push rods. Also visible are the rocker arms that operate to open and close through spring force the inlet and exhaust valves. Thank you for watching this video. For further details, please log on to www.irimi.indianrailways.gov.in. Thank you again.